Okay, I'm only gonna do this because Sam and Bella told me to do this, right?
I hate y'all.
So, Raymond too. So, I saw this problem in my channel, it's there, but I only did part A, so I'm gonna do the whole thing all over again, right? It's the one that resembles the mock, right? So, one of the things that to start off with is FRQ2, Model A, you're gonna go straight to decimals. Your job is to plot these points. This table transferred to decimals as a table, right? So let's do that first before we even bother reading all of this. So if I do that, I go over here to the plus sign, you click table, and then my points are 0, 4, I think I remember it was also 5, 21, and the last one was 8, 14. So again, you have this now, so you need to figure out what type of regression you're going to apply. So here I'm going to click on these little points, add regression, and let's go back and try to figure out, hey, what regression is it? So, where's the equation? The equation's right here. So just by looking at the equation, if they don't tell you what type of function it is, here they tell you it's a quadratic function, right? But you should know that having A, B, and C, and the highest degree being 2, right? That is labeled as a quadratic. So let's do a quadratic regression, right? Now if I go over here, instead of linear, we're going to apply quadratic. Boom. And there it is. So now you have your values for A, B, and C that you need to find on part A2. So let me go back over here. All right. Let me see where I have them. Oh, perfect. So I'm going to have, where is it? A2. I'm going to have 1, 2. Right, so I need a value of A, value of B, and a value of C. So now, if I go to the graph and get this, I have A equals negative 0.716, which is right here. Right, A is the one with the highest degree, B is the one with second highest degree, and then the third one is without a degree, right? Just a constant. So C is equal to 4, B equals 6.983, and again, it's only 3 numbers after decimal. So that's A2, right? So for A1, since we skipped it, let's go back. And it's right here. So all it's telling you is to write 3 equations with X and Y being plugged in into the equation they provided. So then A1 here, I'm gonna have L of T is your Y, your output, right? And then you have T. So if I plug in, replace L of T, I'm gonna have to replace it with 4 first, then you have A to B multiplied with 0 to the power 2, B times 0 plus C, right? And that's one equation. Your output is 4, your input is 0. So you have to repeat this 2 more times. So 21 equals A times 5 to the power 2 plus B times 5 plus C. So the other one is 14 equals A times 8 squared plus B times 8 plus C. There it is. 2 easy points from the 6. What do you do? You're playing out. So that's part A, right? So for part B, you're going to do the same thing. So again, remember, part A, it's any type of function, right? It could be any type of function given. It could be quadratic, it could be exponential, it could be cubic, who knows, right? But for part B, this section right here, sorry, let me go back a little bit. Let me erase this. This section, it's always going to be linear. So B is always going to be linear. Now, be careful, because earlier we plotted 3 points, but now it only wants us to focus from 5 to 8. So what I need to do is go back to my graph, and on this table, I need to take away my first point. So I take away this. Sorry. I take away this and this, right? And then, there you go. I go away from quadratic, and part B is always going to be linear, so I'm going to put linear. And there it is. For part B1, it's asking for the slopes. The slope is right here. This one. That's your answer, right? So m equals negative 2.333. Now, for B2, what you have to do is take this right here, copy it, and then paste it, right? Because now the problem is asking you for an input. I believe the problem was asking you, what is your output if your input is 7? So it's 16.333. That's your answer. So one more time, let me go back to the actual question so you guys can see what I'm talking about. At this point I memorized it. But again, it's right here, input of 7. What do you get for your output? So I just did B1 and I did B2. Very, very simple. The last part though, it's comparing what we called your actual and theoretical graphs, right? So this is considered a tangent line and the other one's considered a quadratic, right? So we're comparing these two graphs that we created, right? We found A, B, and C. We found M and we found B for this one. So now all we do is just graph both of them. So when we graph both of them, if I can find my mouse, it's on here. I go back over here. I'm gonna go here. After you find both of them, right, you just, again, you just plot them, right? Just put them here, and then these are the two graphs that you created. So now, on B3, it's asking to compare these graphs after t greater than 8. So anywhere from here, so 2, 4, 6, 8, right? So basically, it wants us to compare this little section, right? From here, that way. We don't care about all of this. But automatically, I noticed two things. This is a parabola. When you compare concavity, you take into consideration concavity here, right? To find the average rate of change. So this is concave down. So average rate of change is decreasing. But then look at this line, right? Again, this line in red, which is y equals mx plus b, tends to be bigger or greater than this average rate of change shown here, right? So just things to consider. But if we look at the answer key, you should see that they do show you, if I have it, they do mention how it's concave down, right? Which means the rate of change is decreasing, right? And another word that I also mentioned, right? The tangent line is greater than L of t, which is the parabola, the quadratic. So something to look forward to, right? And then finally, the last part. I'm almost done. You good, Sam? So awesome. So I'm almost done. So last part, which is this one right here. It's asking, the Model L is an appropriate model to make predictions about the number of cars in the parking lot if the predicted number of cars in the parking lot is at least 0. Again, when you start counting vehicles, you start out with 0 or any number. There's no negative vehicles, right? So you have to think logically when you're creating these graphs, right? We have to restrict the domain to a certain extent, right? Because we cannot assume there's, again, in this example, negative vehicles. So based on this information, what is the largest value of t? So it's asking until what time is this model appropriate? So we're going to apply domain restriction, right, in a sentence. So if I go back to the graph and just focus here, let me put this away. If I focus here, right, I start there. I start at 0, at time equals 0, and I already have 4 vehicles in place. So all I'm doing now is just basically tracing, right, and trying to figure out until what time is my y gonna be 0. So I keep on going, keep on going, keep on going, and we stop there. If I can zoom out, we stop here, right? T equals 10.28 hours, 0 vehicles. So my model, right, is gonna start here and just keep on going until I end up there. Anything below, we don't care about because there's no negative vehicles. So we have to restrict the domain in this sense, right? So my answer should be around 10-ish. So let's see if we're correct. Let's see the answer key. Here it is. Part C. The model L is an appropriate model to make predictions about the number of cars in the parking lot if the predicted number of cars in the parking lot is at least 0, right? This was the question. So yeah, here it is. L of t when it's 0, which is the number of vehicles, it's at when time equals 10.286. So the largest value of t is 10. And there it is. Hopefully this makes sense. If you have questions, sorry. Alright, but good luck. Good luck.